Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is February 1, 2024, and the time is almost 4:30 a.m. My topic for this morning will be, this will now be the last portion of my topic, long video format trigonometry. This is the last topic. It will be lesson number 54. This involves the so-called inverse trigonometric function. The last time around, I have given you an example problem on the so-called evaluation of an inverse function. So again, for this morning, I will be repeating that one as a last topic, as an additional topic. And so the title of the topic will still be example problem on inverse Trigo functions. Okay, let's proceed. The subject matter for this morning will be trigonometry, lesson number 54. We have arrived at lesson 54 just to complete the long video format topic trigonometry. Almost all the important things needed in the study of trigonometry are already done, so let's try to finish the topic under the trigonometry. So the title of the topic for this morning will be example problem on inverse Trigo functions. Okay, I will try to read the problem. Find the cosine. It's a complicated term. An open bracket, tangent to the minus 1 of 1, plus cotangent to the minus 1 of 2, close bracket. The problem is asking what will be the value of this one. So this is just an evaluation of an equation involving inverse trigonometric function. Okay, let's try to bring out the solution. For the solution, if you try to notice it, the given function is a cosine. We are to take the value of the cosine of these two values here inside. So the first one is an angle, and the second one is an angle. So we are adding two angles here. The sum of these two angles, the problem is asking what will be the cosine value of that one equal to. So to bring out the solution using inverse Trigo function concept, we will let x to be equal to tangent to the minus 1 of 1. Tangent to the minus 1 or arctangent, okay? But to minimize writing, to eliminate that arc thing, we will just place tangent raised to a minus 1, meaning arctangent of 1. So we let x to be arctangent of 1. Okay? Taking the tangent of both sides. The tangent of x will be the tangent of x, and the tangent of the arctangent of 1 will just be simply 1. If we try to take the tangent of the right hand side, the tangent function multiplied by tangent to the minus 1, okay, this will cancel out to be equal to 1. Right? So the right hand side will just be simply 1. Okay? This is the first relation that we brought out from the given equation. We let y also to be equal to cotangent to the minus 1 of 2. It's another representation. We will let y to be cotangent to the minus 1 of 2. Taking the cotangent of both sides, the cotangent of y will be the cotangent of y, and the cotangent of the arccotangent of 2 will just be simply 2. For a cotangent, if we put a cotangent and there is a cotangent to the minus 1, also this will cancel out to be 1. Okay, this is 1 and this is 1. So the right hand side will be just simply 2, meaning cotangent of y is equal to 2. This is the second relation that we derive. Okay, let's try to, since our calculators doesn't involve the cotangent, meaning the other functions, it's just simply the sine, cosine, and tangent. We do not have any cotangent on the calculator. But we know we could compute for the cotangent by just taking the reciprocal of tangent. So, presenting this cotangent in terms of cotangent or tangent, we know that tangent and cotangent are reciprocal. So, if the left hand side is cotangent, we can write this one as simply 1 over tangent of y, and this should be equal to 2. Solving for tangent of y, tangent of y will be 1/2. This is just its sense over 1. We try to cross multiply this one. Okay. So 2 tangent of y will be equal to 1. Therefore, tangent of y will be equal to 1/2. So this is 1/2. Okay. Meaning, we are given an angle y in which the tangent value is actually 1/2. So from this resulting relation here, we could draw a right triangle in which the value of the tangent of the angle y will be 1/2. Meaning, if this is angle y, this should be opposite side, this is adjacent side. Okay, so if tangent of y is 1/2, this should be 1 and this is 2. Right? Because tangent of y will be opposite over adjacent. So if we try to compute for the hypotenuse, this should be square root of 5. Right? 2 square plus 1 square, that will be square root of 5. That's it. For the first one, I think we shall try to go back here. If tangent of x is equal to 1, like on the second one, we are given we drew a right triangle. This is the opposite side, this is the adjacent side, this is angle x. So if tangent of x is equal to 1, what is 1? 1 is just simply 1 over 1, meaning the opposite side will be 1, the adjacent side will be 1, because tangent of x is 1. 1 can be written as simply 1 over 1. So this should be 1, this 1. If we try to compute for the hypotenuse, it will be the square root of 2. That is 1 square plus 1 square, that will be square root of 2. Okay, let's try to go back to the original problem. Okay, so the original cosine of open bracket arctangent of 1 plus arcotangent of 2 close bracket equal to. We represent the first one as x and the second one as y. So if we try to substitute the representation, it will become cosine of the quantity x plus y. Right? And if we try to expand this one, this falls under the so-called expansion of the cosine of the sum of two angles. That is a cosine cosine, sine sine. If this is plus, this should be minus. Okay? So a cosine of the first angle times a cosine of the second angle minus sine of the first angle, sine of the second angle. Okay, I will try to use my eyeglass now. This is very critical now. We will now try to substitute values. We need a value cosine of x. Cosine of x, we'll go back to the first right triangle. Cosine of x will be adjacent over hypotenuse. right? So this is 1 over square root of 2. Cosine of y, we'll use the second right triangle. Cosine of y will be adjacent side over hypotenuse, considering angle y. So this is times 2 over square root of 5. Cosine x, cosine y. This one came from the first right triangle. The second one came from the second right triangle. Minus sine of x will go back to the first right triangle. Sine of x will be opposite over hypotenuse. So this is 1 over square root of 2. Times the value sine of y will go back to the second right triangle, considering angle y. Sine y will be opposite over hypotenuse. So this is 1 over square root of 5. The operation is multiplication. So 1 times 2 will be 2. Square root of 2, square root of 5. Laws of radicals, right? Square root of 2 times square root of 5. This can be written as the product of 2 times 5 under 1 square root, or this will just simply square root of 10. So the product of square root of 2 times square root of 5 can be written as a simplified form. It should be square root of 10. 1 times 1 is 1. Square root of 2 is square root of 5. Same as the first one is square root of 10. Factoring out, there is a common factor 1 over square root of 10. We bring it out. Times open quantity. We bring out 1 over square root of 10 here. So what remains inside will be 2. Okay. For the second one, it is minus 1. We brought out the common factor 1 over square root of 10. And 2 minus 1, this is just 1. So 1 times 1 will be 1 over square root of 10. So if we try to compute for the 1 over square root of 10, that will be an easy one. We'll just display 10 here. We'll take the square root. But that square root of 10 is underneath, so we will take the reciprocal. This is 1 over x. The answer will be 0.31622. 0.31622. Right? So the answer for the given problem will be 0.31622, meaning the cosine of the arctangent of 1 and the arcotangent of 2, close bracket, is actually 0.31622. And how could we verify the validity of our answer if it is really correct or not? That's an easy one. Because if we try to take the cosine of the one inside, the one inside are actually angles. So actually we could compute for the individual angles inside. So to check the validity of our answer, x is actually the arctangent of 1, right? This is the value of the first angle. Oh, that's an easy one. I will just display one here. Arctangent, second function, tangent. This should be 45 degrees. The meaning of this, the arctangent of 1, what is the angle in which, if we try to take the tangent value of it, it's 45 degrees. Okay? If we try to take the tangent value, it is 1. It's 45 degrees because tangent of 45 degrees is 1. Okay? So the first angle here is actually 45 degrees. How about the second one? The second one, the arcotangent of 2, right? Y is actually arcotangent of 2. But this is same as the arcotangent of 1/2, right? Where does this one emanate? It emanates from this. Because cotangent and tangent are reciprocals. So if arcotangent of 2, the equivalent of this will be the arctangent of 1/2. So we'll just place, what is 1/2? It is 0.5, right? Then second function, tangent. 1/2, meaning to say the angle should be less than 45 degrees. This is 26.56 degrees. So the second angle here is actually plus 26.56 degrees. And if we try to take the sum of this one, what will come out will be 71.56 degrees. This is degrees, right? We try to take the sum of the angles inside, it is 71.56 degrees. The problem is just asking what will be the cosine value. So we'll just display 71.56 here. Then we will try to take the cosine value. $45 plus 26.56. Hold on. 45 plus 26.56. Yeah, 71.56. The problem is asking what will be the cosine of that one. 0.316 up to the third digit, same as the answer. So the answer here is 0.316. Up to the third digit is 0.316. If we try to remove the two significant numbers on the right, it points 316. So this is the answer by using the inverse Trigo function solution. And as you check, we solve for the angles, then we try to take the cosine, the value is still 0.316. So meaning to say our answer is actually correct. Okay, that's it guys. That's the solution of the given problem, in which the given problem involves inverse trigonometric function, that is arc tangent and arc cotangent. Okay, this is the last topic under my long video format topic, trigonometry. For those of you who are following my channel is at youtube.com/@ProfDBJ_. I hope you have gained something from my long video format topic, trigonometry. Okay, good morning from Los Angeles. This is Professor DBJ.